PHP 7.4 is no longer actively supported. This means you should definitely be using at least PHP 8. PHP 8 is a major update. It's faster and has many new code features. In this video, you'll learn what these are and how to use them to improve your code. We'll start with named arguments. Before PHP 8, when you called a function, you had to pass arguments in a specific order. For example, the explode function is used to split up a string into parts, based on a specified separator. The first argument is the separator, and the second is the string you want to split up. For example, let's create a variable containing 3 words, separated by forward slashes. To split this into parts, separating each part by the forward slash character, we'll use the explode function. The first argument is the separator, the second is the string we're splitting up. Let's print out the result, and when we run this, we get an array containing the 3 parts the string was split up into. However, if we get the order of the arguments wrong, when we run it again, we don't get an error, we just get an array with one element containing a single slash. This is because the arguments are still both strings, as the function expects. However, this time, the function will try to split up the second argument using the first argument as a separator, giving this unexpected result. PHP 8 introduces named arguments. These allow you to pass data to a function based on the argument name instead of the order. For example, if we add the argument names to this function call, then it works as expected. If you name the arguments, you can specify them in whatever order you like. The original way of doing it still works, but that way you have to make sure you get the arguments in the right order. The names are the names of the argument variables without the $signs, which you can get from the function's documentation. An additional advantage of this is that it's clearer what values you're passing as arguments when you call the function, as they're effectively argument labels. Another advantage of named arguments is that you can skip optional ones. For instance, the setCookie function is used to send a cookie to the browser. It has many arguments: name, value, expiry, and so on. The name argument is required. All the other arguments have default values, so are optional. For example, to set a cookie with the name of lang and a value of en, you would use this code. By not providing values for the other arguments, the default values are used. However, what if you wanted a different value for one of these? For example, the default value of the HTTP-only argument is false. Before PHP 8, to pass a value of true for this argument, you had to pass in a value for all the other arguments that come before it like this, even if these values are the same as the defaults. With named arguments in PHP 8 though, you can do it like this. You can mix positional and named arguments like this as long as no positional arguments come after named ones. So with named arguments, which don't forget are optional, you can avoid problems with argument order, it's clearer what arguments you're passing when you call a function, and you can skip optional arguments. Next, let's look at union types. Here we have a class called discount, which has a single private property called percentage, and a setter and a getter method. This property is only ever going to contain a number. So to enforce that, we can add a type declaration to it. For example, let's specify that this is an integer. We can do this for properties, method arguments, and return values. To see how this works, let's create an object of this class and call the setPercentage method on it, passing in an integer. Then let's call the getPercentage method, and we'll just print that out using var_dump. Before we run this, let's enable strict type checking at the top of the script. When we run it, there are no errors, and we see the value that the getPercentage method has returned. However, now let's try passing a float to the setPercentage method instead of an integer. Now when we run this, we get a type error, saying the first argument must be an integer, but a float was given. If we want to accept both integers and floats, before PHP 8 there was no way to do this with a type declaration. You could add a PHP doc comment block like this, which would help syntax checkers and code completion in some code editors, but it wouldn't check the value at runtime. With PHP 8, we can now add union types. For example, to specify that this value can be an integer or a float, we add the float type, separating the types with a pipe character. You can add more than 2 values if you like, separating each type with a pipe, and you can use primitive types like these and classes as well. These are valid for class properties, function arguments, and return types. So if we change all these to the union type of integers and floats, when we run the code again, now there are no errors and the float value is accepted. There's also a new mixed type available, which represents this union type. However, this covers quite a lot of types, so it's pretty much equivalent to not specifying a type at all, and doesn't really help when checking the type. However, it's there if you need it. Next, let's look at the Nullsafe operator. Let's say we have a variable called session, which contains an object of a class that represents a login session, for example. This object has a property called user, which contains a user object. This user object has a getAddress method, which returns an address object, and finally the address object has a property called country. So to get the value of this country property, we can simply chain these variables together with object operators like this, and assign the return value to a variable. This is fine unless one of these values is null. The getAddress method could return null. The user property could be null, and the session variable itself could contain null. If any of these are null, the use of this object operator will cause an error. Before PHP 8, the way to avoid this potential error was to check each value isn't null in turn, before we try and use it as an object, accessing a property, or calling a method. In addition, we'd also have to initialize the country variable to null before we did all this, in case we never get to this line. PHP 8 introduces the Nullsafe operator. This will only call a method or fetch a property of an expression if it's not null. The Nullsafe operator is the regular object operator prefixed with a question mark. So if we change each operator on this line to the Nullsafe operator, now if any one of these is null, null will be returned, so no error will occur. So in PHP 8, using the Nullsafe operator, we can replace this whole block of code with one line. Next, let's take a look at Constructor property promotion. Consider the following code. We have a class with 2 properties, ID, which is a public integer, and name, which is a private string. I've given them different visibility modifiers just to demonstrate how this works with different property visibilities. Then we have the constructor method, which has two arguments, one for each property, using the same type declarations, integer and string. In the body of the method, we're assigning the values of these arguments to their corresponding properties. This is a very common pattern, to assign constructor parameters to properties, but otherwise do nothing with them. PHP 8 provides a shorter way to do this, known as constructor property promotion. Let's comment this out and make a copy of the constructor method so you can see the difference. In PHP 8, we can precede the constructor arguments with a visibility modifier. This will automatically create a property and assign the value of the argument to it. This code is equivalent to what we just commented out, but is much more concise. So constructor property promotion saves us quite a lot of lines of code, especially if you have a class with lots of properties. Next, let's look at the match expression. Consider this code. Here we have a variable called status code, which contains the integer value 404. We then have a switch statement that contains several case statements. The case statement that will be executed depends on the value of the status code variable. Inside each case block, we're assigning a string to a variable called message. Nothing new here, this is standard PHP. Note, however, that we need to end each case block with a break statement, and that we're assigning a value to the message variable in several places. The match statement in PHP 8 allows us to achieve the same result with less code. Using match, we specify the expression that the result will be based on in the same way as with switch. However, now we can just specify the values we want to match directly. So for values of 200 and 300, we want to return null. We specify what will be returned using this assignment operator. This value will be what is returned from the match statement, so we can assign this to a variable directly. For a value of 404, we'll return the string not found. For 500, the string server error, and the default value we specify in the same way as the switch statement. So this match code is equivalent to the above switch statement, but is much more concise. The next new PHP 8 feature we'll look at are attributes. Attributes are a way to add metadata to your PHP code. These are data that you might have previously put in a comment block, but with PHP 8 attributes, you can get these data programmatically without having to parse the comment block. Let's look at an example. Here we have a class called Controller. To add an attribute to this in PHP 8, before the class we put a hash character, square brackets, then the name of an attribute. For example, let's create an attribute called Setup. Note that attribute names can be whatever you like. So with this example, we might be saying that if this class is part of a framework, we're marking it with this attribute to denote that it's used when setting up the framework. To get this attribute programmatically, we use reflection. So under the class, let's create a new reflection class object for this class. To get the attributes, we call the getAttributes method. Let's print that out to see what we get. When we run this, we get an array of reflection attribute objects. Attributes are added in square brackets, denoting an array, so we can add as many attributes as we need. To get the details of this attribute, we'll access the first array element, which gives us a reflection attribute object, which we can then call the getName method on. Let's run that, and we get the name of the attribute printed out. We can also add arguments to attributes. For example, let's add another attribute called allowed roles. You might use this to denote which user roles are allowed to access this class, for example. Let's pass a couple of arguments to this, for example the strings admin and manager. If we change the index of the attribute we're printing out, when we run this, we get the allowed roles name printed out. Instead of printing out the name, let's call the getArguments method on this, and when we run that, we get an array containing the two arguments. Attributes can also be classes. For example, before this class, let's create a class called root. We define this as an attribute by adding the base attribute class in the root namespace. We add this as an attribute to another class by using the class name. To retrieve this attribute, we call the newInstance method on the reflection attribute object. When we run this, we get an object of the root class we just created as an attribute. As this is a class, we can add methods and properties just like with any other class. Let's add the Constructor method, and we'll use property promotion to add a string property called path. If we run this now, we get an error because we didn't provide a value to the path argument in the constructor. So if we add an argument to the attribute when we add it to the class, for example the string home, now when we run this, we see the object now has a path property with the value of home. You can add whatever properties and methods you need to an attribute class, and access these when you get an instance of the attribute object. In addition to classes, attributes can be added in this way to methods, functions, parameters, properties, and class constants. You can specify where an attribute class can be used by passing the relevant constant when marking a class as an attribute. For example, to specify that this attribute can only be used on a class, we pass the target class constant as the first argument. So attributes are a structured way to add metadata to your code. Examples of why you might use this are to automatically add routes to controller methods in a framework, permissions, event listeners, and so on. Next, let's look at a change to how catch blocks work. Consider this code. If you're calling some code that could throw an exception, and you want to catch it, you put the code in a try block. The associated catch block will be executed if an exception occurs. The catch block includes an argument that represents the exception object that has been thrown. Inside the catch block, you can access the properties and methods of this object. Before PHP 8, this variable was required, even if you didn't use it in the catch block. In PHP 8, however, this is now optional. For example, if we don't want to use the exception object in the catch block, we don't need to include the variable. An advantage of this is when using specific exception classes like this. If you don't need the exception variable, you don't need to include it. While we're with exceptions, let's look at a change to how they're thrown. Let's say we have a variable that could contain null. Before we do anything with this variable, we want to check for it being null, and if it is, throw an invalid argument exception. Before PHP 8, we might do it like this with an if statement. In PHP 8, however, throw is now an expression. So instead of this, in this case, we can use the null coalescing operator and throw the exception directly in here. This is optional, but allows us to write more concise code. Finally, let's look at some new string functions. Before PHP 8, to see if one string contained another, you had to use the string position function. This function returns the starting character position of one string inside another, and false if the string wasn't found. PHP 8 introduces the string contains function, which returns true if the first string argument contains the second string argument, and false otherwise. So now we don't have to check to see if the string position function returns Boolean false. We can just use the string contains function directly. Much clearer if all you want to do is see if one string contains another. There are two more new functions in PHP 8 that work in a similar way. The string starts with function for seeing if one string starts with another, and the string ends with function for seeing if one string ends with another. These functions both return Boolean true or false, and, as with the string contains function, are case sensitive. As you can see, PHP 8 has some extremely useful new features. I hope you enjoy using them. Links to all the code shown in this video, along with links to the official documentation for each feature I covered, are in the description. Please don't forget to like, comment and subscribe, and as always, thank you for watching.